if they decided to tackle the same problem today, they probably would have stuck on the open source path and realized that because open source service mesh is in lockstep with open source container orchestration systems, is in lockstep with a lot of other ecosystem solutions, it makes much more sense today than it did 5-6 years ago.
This is DevOps Paradox, episode number 238, Unlocking the Potential of Modern Architectures Using Service Mesh. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsa. Victor, you just got back from KubeCon, and besides all the AI things, I imagine one of the items that still keeps on raising its head is service mesh. Was that true or not true?
It must be true, yes. Because service mesh is extremely important, but it starts as a very boring thing that nobody, it's networking. Who cares about networking? Nobody, right? And that's probably because, networking from the past is, okay, how do you move packets from A to B, right? But it really enables certain things that we didn't have before or were very difficult before. So yeah, it's still a thing.
So people do not care about networking until they have to care about it.
Exactly. But to me, sounds special about service mesh is that, networking itself is important for a very, very small number of people, right? The people who care about networking. With service mesh, there is something for almost any type of expert, right? There is something for application developers, something for security people, something for whomever else, right? Even for testers in a way.
Experts. Thankfully, we have an expert on today about service mesh. We have Marino on from Solo.io. Marino, how are you doing?
I'm doing very well. Thank you for having me on board.
So, service mesh. I imagine you live and breathe this on a daily basis.
I actually do. You're absolutely right, Darren. I've been living the dream of the mesh since late 2020, somewhere around that time frame.
You say you've been living the life of that, but that's only 3 years. I mean, in internet time, that's nothing, right? Or is it a lot of time?
It's a lot of time when you think about how much happens in the open source world as a service mesh has to continue to be better, right? You think about what people are trying to do. I mean, Victor just laid out a whole bunch of different capabilities and use cases and consumers of that technology. But if you have all of these different perspectives using this tech, what you're going to find is a feedback loop that comes in and only improves upon that technology. So it feels like within those 3 years, service mesh has gone from 0 to 150, just like that.
If people don't understand what a service mesh is, can you just boil it down into like a nickel tour?
Yeah, let's think about how we used to do networking a long time ago. So we had this pattern where we had clients that needed to communicate with other networks or other clients, and they needed this intermediary device called a router to help us get there. And quite honestly, it's doing some simple logic. It's making decisions based off of what it knows and what it can help us get to. But at the same time, I mean, we are limited in the kinds of deeper decisions and policies we can apply to workloads, to clients, to what they're trying to do. And so when you start to transcend that pattern and go beyond it, you start to let's look at the OSI model for a second. That intelligence lives at that top layer, what we refer to as the application layer. And so we can bake in metadata, we can bake in identity, we can bake in some form of authentication so that now, based off of these attributes, clients have a better way of routing. Clients have a better way of making decisions of the way they transact with other services in their network. Now, to think of what we're doing, we're actually taking this concept of an API gateway. API gateway is just a way that we can transact with services without having to directly transact with them. But if you take that principle of API gateway and you spread it to every single service, you're now taking that same functionality, putting it alongside that service, and achieving an immense amount of scale without depending on a singular device that could potentially fail.
So what makes Service Mesh then better choice than API gateway? You just described kind of that both are doing something very similar, if not the same, right? According to what you described so far.
Yeah, I think there's a belief that you are overlapping with the two technologies, right? But the consideration comes down to how you've built your pattern. The traditional API gateway wasn't truly meant to scale with the way we built our applications. So we're not talking about single monoliths anymore. We're talking about monoliths and microservices and everything that can show up in between. And so you can't take a singular enforcement point and have it be responsible for all of these different kinds of workloads. But you can take that single enforcement point, duplicate it in so many different ways, and you could multiply it, replicate it, have multiple copies of it doing the same thing. So now you spread that load, kind of like how you would do with a load balancer. And so when you think about that particular approach, you're now still giving yourself the API gateway functionality, but now everyone is treated as an object that can get it or have access to it. Now, there's other parts to it too. It's the way you deploy your applications. It's the way services inside of your cluster communicate with each other. So I'll bring up a very interesting point. Back when we managed data centers and branch locations, we would deploy firewalls at the edge. And these would be perimeter-based gateways or devices that would intercept traffic on the ingress and potentially filter traffic on the egress, right? So maybe you want to block certain websites that folks shouldn't be going to or services shouldn't be tapping into. But here's the reality. When you have services that communicate amongst each other within your data center or within your network, they don't ever traverse that gateway or that firewall. And in a similar fashion, when you think about API gateways, if you haven't tuned it as such, then all of your traffic won't ever go direct up to an API gateway. It'll always go direct. It'll go east-west. And so we want to be able to address all kinds of movement in the way we transact with our services. So this is why Service Mesh is superior in a lot of ways to an API gateway, but still offers that functionality.
My introduction to Service Mesh had nothing to do with networking, or at least I thought that it has nothing to do with networking, right? Years ago, I don't remember anymore how long ago, but I was looking for a way how I can implement blue-green deployments in Canary releases, right? Zero interest in networking. I did not care at that time about TLSs and security and all those things. How can I do Canary deployments, right? Eventually, I figured out that I don't even remember. I think it was Linkerd or Istio that I stumbled upon. To me, the interesting part of that is how you can get to it in a way from very different directions, right? How somebody might have realized that they have a need for Service Mesh, even though that somebody is not really that interested in how do I get a request from A to B, right?
You're absolutely right. I mean, the networking use case is one like I'll naturally gravitate towards because I'm biased. I have a networking background, and so I like to have that shine whenever I talk about a mesh. But there are some other key things you brought up. You brought up the whole notion of how I release software. And so when you're trying to release software, you have to consider how you cut connections over or facilitate a cut of that continual transaction to a service without impacting that end user. And so service meshes help facilitate things like rollouts for blue greens or canary deployments. Then there's that security aspect of it, right? That whole concept of why we have something like MTLS is for two reasons. One is because we want to identify and authenticate whoever is in that mesh, whoever is operating in our environment, but also provide a mechanism for encryption. So in the normal networking world, and I know I keep going back to this, we use technologies like IPsec to achieve that. But we couldn't take IPsec, a VPN tunneling technology, right down to a service, a client, without compromising something. That compromise happens to be CPU and memory, because every time we have to send traffic, we have to encrypt and decrypt. And that takes up cycles because it takes up calculations to do that decryption and encryption, right? But now with the mesh, that all gets offloaded. We do this elsewhere. We don't have to necessarily do it inside of our user space anymore. And so it gives us a nice pattern to operate from. But the interesting part is we're taking from the networking world, bringing it into that cloud native space and just doing the same things over again, but smaller. Now there's that one more use case that we really care about, and it's how our applications are doing. It's literally how they are responding. If they're responding, are they available? Is our business able to keep up with their own SLAs mapped to these technical SLAs that we have? And so the upkeep of services is what a service mesh is trying to do, making sure that they're always available. But it can only do that if we can see how these services are behaving. Perfect example. I get 100 404 requests or responses in a row. What does that tell me? Is that a situation where the actual service is unavailable, or have I created a policy to specifically block that? But that observability piece, that's what it is. Observability is critical to us for us to help us decide how we want to build a resilient microservices application. That observability is going to tell us latency information. That observability is going to tell us the request path between all of our services that have to interact with each other to provide us with a response or a result.
I look at those things from a different perspective, more from a developer background rather than networking. And to me, another fascinating thing is that finally those things are decoupled from applications, from the source code. I remember a long time ago that one of my worst experiences was putting, for example, certificates into applications, right? So that they can communicate with other applications in a safe way, what today we know as MTLS, and so on and so forth, right? To me, that ability to say, you don't really need to worry about those things, right? You don't really need to think about them when you're writing application code. And yet all those things will somehow auto-magically happen. You will have MTLS, it will be secure, it will be authenticated, and so on and so forth, without impacting. No, actually, we are impacting, but without affecting the productivity of developers who are eventually writing the code that will do something is a huge boost in productivity.
You're absolutely right. I think when you look at what Java offered us many, many years ago, to be able to do things like service discovery or circuit breaking between our services, these are starting points. These are where these concepts originated from. But you had to pull on the correct libraries, add that to your code base. And anytime something changed, well, that's an update. That's an automatic update. But you're not lifecycling the application itself. You're lifecycling a component the application needs to communicate with something else, to discover another service. So the notion of actually decoupling that functionality and moving it off to something like a service mesh sidecar is exactly why we're here, right? The service mesh sidecar can be upgraded independently of the application. The application can be upgraded independently of that sidecar. However, we can still facilitate all those communications through that proxy. All that circuit breaking that we need for the resiliency comes from that proxy. And so for the developer, that productivity isn't hindered in any way. I'll write code, I'll keep packaging it up. I'll just identify the service that I want to talk to, and then I'll let the mesh take care of everything else for me. And that's the critical part of it. That's why we want to make lives easy for developers, because they should be focusing entirely on writing code iterating on that code, making changes, and let the platform teams worry about the connections, instrumenting the observability, and rotating things like certificates.
I mostly use service meshes within Kubernetes. Is that where it still exists, or is it expanding outside? Are people implementing or using it to connect other types of workloads?
Yeah, I think it's very tied to this notion of decoupling, right? We didn't want, well, when you think of the service mesh community, that whole idea of service mesh was derived from technologies years ago. But when we brought it up with the world of Kubernetes, there was almost this level of coupling going on. So because of that coupling, you almost felt like you had this dependency. You needed this to run. You needed Kubernetes to run. Now, the reality is today, and going back to what I said earlier, there are a variety of styles of workloads that show up. And so if you are entirely dependent on Kubernetes, how do you attach yourself to other workloads? So the open source world has to be inventive and has to navigate ways to be able to handle workloads that don't run as containers. Like databases don't always do well as containers, or certain legacy applications that have been built with a hard-coded bits and parameters in mind might not be best containerized, but we still need to find a way to get them into our fabric, our mesh. So let's take Istio, for example. Istio today, I mean, after several iterations and enhancements, gives you that flexibility, right? You take the sidecar model and you're deploying it on an operating system. You're deploying it on top of a VM. You're deploying it on top of a bare metal host. And it's documented. You can go and see it. Is it easy to do? No, because when you think about how many, you think about the scale, having to sit there and manually plumb every single one of those non-containerized workloads into your mesh is not easy, right? So there are enterprise solutions that solve this problem. The company I work for has an excellent solution that does that very well, handles non-containerized based workloads and containerized based workloads as well. And that's important, right? And so to answer your question, I'm fairly certain like all meshes are able to do this cleanly today. You take Istio, it does it. I can't say for sure about some of the other ones. I know Cilium is well on its way to being able to support it, and I think it already does. I know Kuma Mesh has that functionality. And so there are others out there that are looking to achieve it. Maybe some aren't built to be focused on doing non-containerized based workloads and just want to focus on containers. In fact, that concept of taking the mesh outside of Kubernetes, right? Here's a good example. You know how you have a VPN client on your system because maybe you go to a country and you want to be able to access your servers back home, or just maybe hide your access or where you're accessing. That idea is now just making its way to VMs. That's all it really is. All it really comes down to. We take a VPN-like technology and stick it inside of the operating system as a user space proxy. And then it proxies those connections, those specific connections going to anything in the mesh, which is nothing different than what we used to do years ago, except it's just built differently.
Most of these are implemented using sidecars, correct?
That's correct. Actually, when the first few meshes came out, and Linkerd was one of them that did this, they actually had this node level proxy. In Linkerd version 1, it was a node level proxy where all connections would have to traverse that proxy to communicate with other services or endpoints. And then the sidecar model was born, where you would basically roll services into a mesh, and those services would have sidecar containers attached alongside their main containers. And so through service-to-service communications, it all happened through that proxy. And so Linkerd did this. They had a Rust-based proxy. Istio does this with the Envoy-based proxy, and several others do something similar as well. And then you started to see a pattern where we wanted to move back to a sidecarless model. So sidecars were the star of the show for many, many years, and they still are. But there are workloads that don't really benefit and actually get hurt by having a sidecar in place because of a slight additional bit of latency that gets added that could impact the request and a response of a workflow. So you have some things like ambient mesh that show up. That is a sidecarless model and another mode of Istio that doesn't really change much other than if you have a desire to run non-sidecar based workloads in a mesh, you can get that. And it's offered up through some things called the Z-tunnel and the Waypoint proxy.
So what was going back a little, what was the benefit of the argument when people started moving from node proxies to sidecars? Was it more flexibility or?
So it's a combination of things. One, you didn't want to have a single point of failure at the node level. So if you're having a node level proxy handle and proxy all communications, if that proxy disappears for whatever reason, your workloads won't have the ability to transact on that local node, right? But that could be an underlying issue for a variety of other reasons. It also wasn't a true shared tenancy model or a multi-tenant model. That is an inherent security risk. Whereas if you drop to the sidecar model, each sidecar is in its own little tenant or its own little network namespace. And so you now increase your security shift by adding in sidecars, or you increase your security footprint by adding in those sidecars. But when it comes to, okay, but wait, well, we are now moving back to that almost node-like proxy. Well, in something like ambient mesh, it's not meant to be perceived as a node-level proxy. It's actually meant to be perceived as a remote proxy. So still a decoupling, right? Still a decoupling from the main application container, but still in line in the data path so that the sidecar-like functionality is still present. But it also becomes multi-tenant because now you can leverage service accounts and their identity for this quote-unquote node-level proxy to be able to assume each one of these workloads and their identity appropriately. And that becomes important because when you look at the traditional node-level proxy approach, it wasn't like that. It didn't discern identity. It's just we're looking at endpoints with IPs and they're communicating outbound. There are two modes that are preferred today. It's the sidecarless mode if you have like server send first protocols or highly latency sensitive applications, or the sidecar model where everything gets a sidecar, or you could have both.
It seems like that last option would be the worst of all possibilities.
With the both situation where you have sidecar and sidecarless.
Correct.
Well, I like the way Kubernetes was architected because everything now is a namespace, or you can treat it as such. You can carve it out as such. It's not tenancy at that point, but it's the way you decide you want to partition your workloads or create some logical separation without a true boundary in place. It's more of a logical boundary. But because you have this namespace concept, you now have this ability to use it as a grouping mechanism to say workloads in this namespace should be in the mesh, while workloads in this other namespace don't need to be in the mesh. Now, when you break that down even further, you might have workloads that need the sidecar. So you'll have three namespaces. Two of them are going to be in the mesh. One of them is going to have sidecars. The other one is not going to have sidecars. The model is there to give you some flexibility in how you want to deploy your workloads and the way you want to attach them to the mesh. But you have to understand that with these kinds of architectures, there are going to be some trade-offs. So we could get into the trade-offs. I don't know if we want to do that right now, but it'll always come down to what your application requirements are.
So if I would now be choosing between sidecars and sidecarless or no sidecars, is there a simple one or two sentences I would use, or that's a much more complicated reasoning that would lead me to one choice or another?
If you plan on doing this in open source, sidecarless is not 100% ready. If you plan on doing this with enterprise-grade commercial offerings, there are vendors out there that are ready to support both models for you however way you want. And I work for one of them.
I meant more like how would I choose what is the any way I want? Let's say that I'm using enterprise, kind of the best, whatever the option is there,
yeah.
right? What would, and let's say that I'm your customer, right? And dear Marino, should I do A or B?
It becomes a very challenging answer because it's not going to be either or. It's an assessment of what's required for your environment. And maybe it could be either A or B, or it could be both. And that's the beauty of the technology. I mean, it'll support both. Open source can't support both today. But if it comes down to it, you can start with the model where you're slowly, incrementally onboarding services into the mesh in a non-intrusive manner. And that could be it, right? That could be the one key trigger that says to you as an organization, I want to use service mesh functionality, but I do not want to take anything down. Nothing should go offline. I don't want to roll out any of my services all over again, but I still want the service mesh functionality. Well, then that almost pushes you to a sidecarless model, because a sidecar model is intrusive. You can't simply drop in a sidecar, cut your networking, and then expect it to be a part of the mesh. That has to be reworked. And so in a lot of meshes, when you have a workload already deployed, in order to roll out that sidecar, you have to re-roll out the deployment all over again. And then the sidecar gets in first before the application container comes on. It's an operational burden at this point. Do you want to take some downtime or not? There's other situations too, right? Where you might be running at the edge and you're limited in resources. And so you have to consider ambient mesh or a sidecarless model means less containers running overall, less CPU and memory required, less management of those containers, but still mesh functionality. So the edge might be a place for it.
Until you said that, I would have swear that it would be the other way around, right? That sidecar would be potential burden on resources because I'm running, I don't know, 50 or maybe 100 pods in a node. But when it's edge, right, I'm probably running something on the edge. I thought that it would be kind of sidecar would be that smaller one, but I'm probably wrong, right?
Yeah, I mean, there's some interesting models that have started to show up. I will say that we just did a talk at Edge Day at KubeCon that specifically addresses running a sidecar-based edge model and a sidecarless-based edge model with service mesh. The idea is you have a Kubernetes cluster running somewhere up in the cloud, or it could be local, and then you have two Raspberry Pis. One has a sidecar, and one has a quote-unquote sidecar. The real subtle distinction between the two is that the first Raspberry Pi has a regular sidecar that you normally would see in regular Istio. So you can pretend that it's, in the mesh, it's a container, but it's actually not. It's a real Raspberry Pi. And then the other one is the sidecarless model, where we're actually still dropping in a proxy. And so the reason we have these two models set up is really for that lightweight operation. Maybe we don't have full-blown Kubernetes, but we do have just an edge workload, and we still need mesh functionality. We still need telemetry. We still need MTLS. We still need to push policy right down to that workload, but we don't want the overhead of Kubernetes.
Is there a distance when service mesh becomes unattainable? So if my edge is on the other continent, would I still put it in a service mesh, or there are certain limits?
At that point, you'd start to consider creating a multi-control plane setup and create your control planes that are much more geographically closer to those edge points. So you might have a multi-cluster mesh setup. And you do that because, one, you obviously want to have some tolerance in the way you set up things, but also for the way the control plane communicates with the proxies using, XDS. Distance impacts latency. Latency impacts updates. So configuration like policy can't get realized quickly enough. If especially you're using a model like a GitOps model, for example. When you consider that for a second, if you're not able to realize policy quickly enough, and for example, there's a vulnerability that has been pushed out or has been made well known by everyone, you have a patch for it. You already know how to prevent it. Let's say we're talking about Log4Shell, right? Maybe it's a simple virtual service configuration update that needs to be pushed to the edge. The fact that we may not have a local control plane or a control plane that's close enough to push that update in a reasonable amount of time could be the window of opportunity for that attack to occur or that exploit to occur. So while, there's no hard set figure here, it really comes down to how much latency you're faced with and how you're able to communicate back with your control plane.
In this context, I guess when you say control plane, you mean both control plane as in Kubernetes control plane, but also where the service mesh plane is running, right?
Specifically the service mesh control plane, because we're at this point where we have independence of the Kubernetes control plane. We can run workloads without Kubernetes, but still have them in the mesh, and that's the beautiful thing about it.
When we're talking about the sidecarless, I'm just trying to get my head around it. Obviously, when you're running a sidecar, that's just another container in the deployment. That's easy peasy. But sidecarless, is it just a binary that gets installed? Or do I dare break out the 4 letters that everybody wants to say today, eBPF?
It actually has nothing to do with eBPF. And that's the second part of that answer. But the first part is really taking that sidecar and now making it more like a node level proxy, but not a node level proxy. Because the perception and the optics should never be that it's a per node model, but it can operate per node and you can scale it. So you could have multiple copies of it. So you could have multiple proxies doing the same thing, doing load balancing, but they're sharing the load together on a singular node. Now, what does that actually look like? What does that mean? So the sidecar model, the sidecar itself is the Envoy-based proxy. This highly powerful layer 7, layer 4 TCP, HTTP-based proxy. Can do a lot of things. You can customize it. You can even run virtual machines in it or WASM-based functions in it if you wanted to. But the real intention of it was to intercept traffic and know what to do with it, how to move it, and then at the same time, discover services, discover routes, discover ways to get to these other services. Now, that model was brought into the world of service mesh. You layer in a control plane on top, and now you're controlling these and configuring them at scale. Easy enough, right? Now, the one challenge, though, is that Envoy itself has a massive surface attack area because there's just so many things. In fact, because of layer 7, because of the HTTP modules that exist, that in itself is a huge vulnerability waiting to happen, right? And so you see Envoy getting patched quite frequently and locked down in certain ways. But if we want to move to a much more secure model and also cut out a lot of the bloat, well, we can do a number of things. We can turn off a bunch of services in Envoy and still use Envoy, or we can rebuild the proxy and just do the things we wanted to do, like MTLS, connection handling, and then the last thing would be some telemetry. Enough to know what's going on. And even policy, like layer 4 firewalling policy, basically. So what ended up happening was that proxy functionality was taken and broken up into 2 things. Something called the Z-tunnel, which is what I just described, a much more smaller footprint proxy. That is what we operate with a sidecarless model or an ambient mesh for Istio. And then something called the Waypoint, which is still full-blown Envoy, does the layer 7 stuff for us, but is only deployed on an as-needed basis. And that's how you have ambient mesh.
What is the as-needed base? When is it needed?
So think about the times where you want to do some circuit breaking or some delays or fault injection, or if you're actually attempting to do those blue-greens or canary deployments. You need something that understands layer 7, something that can read and understand the attributes and the metadata in that HTTP header. The layer 4 proxy can't do that, but it's optimized for speed, just pushing out requests and connections versus analyzing them in depth and detail. So with Envoy, that's what it's doing. That's what it's meant to do. That's the engine it has. It'll analyze that HTTP header information, understand what that metadata is, look for identity, look for any sort of certificate information, look for any sort of other attributes that might be very specific to the destination it might mean that request might need to be routed towards. But that's something only Envoy can do. So as an as-needed basis situation, if you don't always need to do canaries and all you're really doing is service-to-service communication, maybe it's just zTunnel and layer 4. But when you start launching and releasing, that's where that proxy comes in.
If you do have both installed, running, is there still some kind of logic happening in the background? Hey, I don't need to go to layer 7. I just need to send this directly. Or Victor is going crazy and it goes to layer 7, right?
Yeah. I'm trying to help find a way to visualize this because we're doing this over audio. But let's just imagine we have two services that are communicating with each other. Now, if they're freely communicating plain text and they know about how to get to each other, that's perfect. But once they are now moved to separate nodes and now there are two nodes in the mix and we want these two services to be communicating with each other, we'll implement, let's say, ambient mesh just for fun. So ambient mesh enters the chat. We now have zTunnel deployed on each node. So traffic from service A on node 1 going to service B on node 2 will always pass through the zTunnel on node 1, and then we'll hit the zTunnel on node 2 before it goes to the destination service B. Now, this is all layer 4. Nothing magical here, straight up IP connectivity with some TCP magic mixed in. When we start throwing in policy, I don't want service A to run an HTTP delete operation against service B. It can only run an HTTP get operation. There is a waypoint proxy that is deployed to the destination location or the destination node. And it actually is a hop that is added before the service or the final service gets communicated to. So the hop looks like this. Service A, zTunnel on node 1, waypoint on node 2, zTunnel on node 2, service B. What the zTunnel is doing is just managing identity all throughout and tunneling. What the waypoint is doing is processing layer 7, but terminating the tunnels between these connections.
It's interesting that you're putting waypoint only on that second node. It seems like I should never even be able to leave my first node if it's a policy that is supposed to be system-wide.
Well, it's a specific policy. It's an intentional policy, and it's very directional too. Now, that service could be replicated to another node. There could be 3 nodes in your cluster. That's not to say you're going to deploy another waypoint proxy to that third node if you had 2 copies of it. Because remember, we have to treat these as remote proxies and not the traditional node level proxies. So we just need a place to put them. We don't necessarily need to gravitate them to a particular node and say, this is assigned to this node only, and that's all it can do, and it can only service these workloads.
Whereas zTunnel does need that because that's the bottom.
There is some gravity towards it because it's solely responsible for the workloads that it's tied to and the node that it's running on.
Yeah, so I'm having to basically break old thinking here because I'm just thinking basic. Let's go much simpler. If I am submitting an HTTP form, I should be validating the form, but I also need to be validating the service that's receiving that form data, right? So that was my thinking here is that, okay, I actually need a waypoint on the egress and on the ingress, but that's going overkill. I just need waypoint and then let the ambient deal with the rest of it.
Pretty much so.
What is the craziest thing you have seen somebody try to do with a mesh?
That's an interesting question. I think the crazy, I don't like to use that word, but I will say that there have been some extreme situations where the mesh, so in the open source world, right, you have limited support, but you have all of this outpour of community support, right? People will come in and add so much context and whatnot. There have been meshes out there that are built that have now become problematic because someone built on top of an open source project. They continue to build on top of it, right? And now you get into the situation where you've built so deeply on top of it, you now own it. No one else owns it. No one else has your corner cases. If you can think for a second, right? I can't name the name, but if you can think for a second, at the scale at which they operate, it becomes very challenging to do updates. It becomes very challenging to become almost in lockstep with what's going on in the open source world. And so you've massively drifted away. Have you ever watched, there's this show, and it came out on HBO. It's like the Space Odyssey, but it's also a comedy or something. Avenue 5, I think that's what it's called. So it's with Hugh Laurie, right? And they're all on this, and I don't want to give the entire plot line away, but they're on this like space vacation, and something like sets them off course by like an inch or something like that. But because of that, and because of the trajectory they're going in, they keep going down that path. And for them to get back into the original trajectory, it would take them like tens of years or something to that effect. I can't remember the actual figures. That's what this customer got themselves into. And so what do you do in those situations? It can be very cumbersome to walk back from that. And so you poured an immense amount of investment. You've diverged from the traditional open source path and even open source practices. But now you're in a situation where you have to own it and support it yourself all the way through and through. Now, if that team leaves, whose problem is it at that point? And if there's not enough documentation to cover it all, well, you'll just have to pay a bunch of consultants to come in and figure it all out for you.
I always had trouble understanding why people do that, right? Why not contribute back to improve the functionality of a project that you're using, instead of going down the path where you know that you're going to be shot in the back for doing that and diverging from whatever you're using? It's a mystery to me.
It's very much a mystery. It's also explainable in a few ways, in that some people or folks feel, and this could be career oriented, right? Like, hey, this is the best way to secure my spot here at this organization. There's another side to it too, right? Where you have organizations that build something that have to be proprietary because there could be some very telling details about strategies around maybe things that certain government organizations are doing. So there are reasons backing that. But on the other hand, you're absolutely right. If you paint yourself into that corner and you don't send that back into open source and then have other folks contribute to that, now you're stuck. You're on your own. You're basically the only one having to support this. But there are cases like that. And in fact, a case like that came up recently, which is pretty much why we were just talking about it. And so when you've actually gotten to that situation, it becomes even incredibly harder to adopt something like ambient mesh.
I was going there because I imagine that ambient mesh, I'm now guessing, correct me if I'm wrong, right? They created also paths how to move from whatever was before to that, right? Kind of the pathways or transitions to the new stuff that exists only for the pure users, right?
Yeah, I mean, if you're a purist at this point and you've stuck with the open source path, then it becomes very easy to transition to the way you want to. Or if you stuck with a vendor that has aligned themselves to open source, it's easy. But once you've diverged, right, you question, right? You question, one, the value of what you've done as an investment for the last 5-6 years as you built out a service mesh or built on top of a service mesh. And then you decide, like, am I going to drop everything I've done, turn this into technical debt and move over to something new, right? And that's a hard one. It's a really hard one to answer, because if that model also works really well for you, right? And if you've got a supported model for it, you know how to work through issues, then why change? There's a lot of different ways to look at it.
That story actually leads me to the next question I was going to ask. When should you not use a service mesh? And it seems like that whole story is one of the reasons why you would never want to use a service mesh. Is because you started out with good intentions, but then went sideways.
If you look back to the early history of service mesh, and we're talking about the era of once Kubernetes launched, the next hottest thing was supposed to be a mesh. It actually was extremely challenging to get meshes up and online. If you actually did service mesh the hard way, we're not even talking about, a control plane that you deploy. You're literally standing up a certificate authority. You're having to manage the process of certificate rotation, issuances, all that fun stuff. Then you're also having to instrument observability manually, and then you're also having to plumb the networking manually. These are the base functions of a service mesh, right? And when you think about way back then, a lot of this didn't exist. And so you had someone that decided this is a great technology and concept and idea, but I needed to do more. So they'll take it, they build with it, they build on top of it, and then they make it their own. They make it their own baby that they grow into a teenager and then to an adult. And now they're responsible for it for the rest of its life. But this is a symptom of the fact that it wasn't ready for them back then. They had to make it ready for them. Whereas today, if they decided to tackle the same problem today, they probably would have stuck on the open source path and realized that because open source service mesh is in lockstep with open source container orchestration systems, is in lockstep with a lot of other ecosystem solutions, it makes much more sense today than it did 5-6 years ago.
So with all of that in mind, you work for Solo.io. Tell us what Solo.io would give us over open source.
So one of the critical considerations is around toil, stitching, piecing together multiple components to be able to have a fully functional multi-cluster, multi-service mesh. Now you can do it. You can absolutely do it yourself by hand. You can sit there and build all the trust between all the different components manually by hand, but then you also have to be responsible for rotating everything. You have to be responsible for the instrumentation of how you see things, how you understand how services are performing. Instead of having to do that by hand, you could automate it. You could use something like the GitOps model. You could use Argo CD to help with some of this too. And you could build that yourself. And we're going down this path of I could build it myself, I can automate it, etc. But this is exactly what Solo built. They realized that beyond the API gateway need, and when they jumped in when folks started using API gateways and offered up API gateway functionality, they started to notice, hey, there are folks out there that need to use service meshes. Let's offer them up an abstracted service mesh offering that simplifies how they configure a mesh, that does it for multiple clusters, that does it at scale, that also helps them with the lifecycling of software. So whenever there are updates, we can help them update their environments. But not only that, right? There are things that open source doesn't offer. What about ARM? It wasn't around for a long time. What about FIPS? FIPS support wasn't there, and it still isn't there. So where do you get this from? Do you build it yourself, or do you have someone else that can own that for you, build it and maintain it? So this is exactly what Solo does. Multi-cluster application networking that gives developers an API and platform teams a foundation to run services on top of and operate them at scale.
So Solo is at solo.io. That's SOLO.io. Marino, thanks for being with us today.
Thank you so much, Darren, and thank you so much, Victor.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.